Hello everyone, welcome to my physics class. I will try my best to make you understand the concept of different types of motion, speed and distance, uniform motion, non-uniform motion, mass and weight. In the previous class we discussed about motion and rest, and rest and motion are relative terms. Today I am going to discuss about the different types of motion which we observe around us. So what are these different types of motion? You see objects around us execute different types of motion such as oscillatory motion, repetitive motion, rotatory motion, circular motion, curvilinear motion, translational motion, rectilinear motion, random motion, oscillatory motions. These are the different types of motion that execute around us. We discuss about the different types of motion one by one. First we discuss about the translatory motion. An object is said to be in translatory motion if it moves as a whole. It means that if all the parts of an object moves the same distance in a given time, then the object is said to possess translatory motion. Translatory motion is further divided into two types. One is rectilinear motion, means the motion is in a straight line, and another one is curvilinear motion. It means that the motion is along a curved line. So now we discuss about rectilinear motion. What is rectilinear motion? An object is said to be in rectilinear motion if it moves in a straight line in a particular direction only, in a one direction only. Some example of rectilinear motions are a boy running a 50-meter race on a straight path, a car is moving in a straight line in a particular direction, the movement of striker of carom board, in a particular direction. This all execute rectilinear motion. Now curvilinear motion. This is another type of translatory motion. An object is said to be in curvilinear motion if it moves along a curved path. If the path of the motion of the body is a curved one, then the body is said to have curvilinear motion. Examples of curvilinear motion are a train moving on a curved track, a car moving along a curved road, a basketball thrown in a basket which follows a curved path. Now we discuss about circulatory and rotatory motion. An object is said to be in circulatory motion if it moves around a fixed point. Examples of circulatory motion are motion of the blades of windmill, motion of car's wheel, motion of the satellite orbiting around the earth. These are the examples of circulatory motion. Now rotatory motion. An object is said to be in rotatory motion if it moves on its own axis. When an object moves about its own axis, then the object is said to have rotatory motion. For example, some examples of rotatory motion are rotation of earth, spinning of a top, now oscillatory motion. An object is said to be in oscillatory motion if it moves to and fro about a fixed point. If a body moves towards and forward and backward about a fixed point, then the body is said to be in oscillatory motion. Some example of oscillatory motions are the motion of a swing, the motion of a pendulum, swinging pendulum. These are the examples of oscillatory motion. If we pull one of the branches of a tree towards you and then leave it, then the branch of the leaf will also execute oscillatory motion for some times. So, these are the swinging of pendulum, which moves forward and backward from its position. The motion of a swing from its mean position, the swing moves towards and backward. So the motion of a swing is classified under oscillatory motion. Now repetitive motion. An object is said to be in repetitive motion if it repeats its motion. Repetitive motion is divided into two types. One is periodic motion and non-periodic motion. An object is said to be in periodic motion if it represents the motion after regular interval of time. Some example of periodic motions are the motion of the earth around the sun. You know that the motion of the earth around the sun, which takes 365 days to complete one revolution around the sun. So the rotation of earth on its axis, rotation of earth around its own axis, it takes 24 hours to complete one rotation about its own axis. So after every 24 hours the motion completes one rotation. Movement of hands of a clock also execute periodic motion. Non-periodic motion. An object is said to be in non-periodic motion if it does not repeat the motion after regular interval of time. Some examples of non-periodic motion: blinking of our eyelids, a car moving on a rough road. While the car moving on a rough road, its the speed of the car somewhere increases and somewhere decreases. Sea waves, motion of sea waves. Now random motion. An object is said to be in random motion if it changes its direction in a regular and irregular manner. Some example: flying kite. A flying kite changes in direction randomly, so the motion of the flying kite is random motion. Bee flying in a garden. The bee flies here and there in the garden. It does not move in a particular direction. It moves in one direction, another direction, in everywhere, here and there it moves. So the motion of the flying bees in a garden is also random motion. Hockey or football players on a field. The hockey and football players move randomly in any direction of the on the field, so their motion is also random motion. Another one is multiple motion. When a moving object possesses more than one type of motion at a time, it is called multiple. Then the object is said to have multiple motion. The motion of the earth. The earth moves in a circular path. This motion repeats after regular interval of time, so it is periodic also. Periodic and circulatory. Now distance and speed. Distance is the actual path covered by a moving object. The unit of distance is meter. Meter is measured. The distance covered by an object is measured in meter. Speed is the distance covered by an object in unit time. Speed is the ratio of the distance covered by an object to the time taken by the object to cover that distance. It means that slow moving object move at a slower speed as compared to that of fast moving object which moves at higher speed. An odometer is a device that shows the distance traveled by a vehicle in kilometers. So the speed of an object can be calculated by the formula speed is equal to distance traveled by time taken. The commonly used units of speed are kilometer per hour, meter per second. The speeds of car, bus and other vehicles are measured by a device called speedometer. It indicates the speed of vehicle in kilometer per hour. See, this is the speedometer. This indicates this hand reads the speed of the vehicle, and here the distance is indicated in kilometer. Speedometer and odometer. In vehicle there is a speedometer which displays the speed of the car or at any moment, and odometer displays the distance covered by the car. So these devices are considered as the most important device to measure the physical quantity of a running car. So let us consider that the car covers a distance of 1000 km in 2 hours. So by using the formula for speed, we know that speed is equal to distance by time. So distance covered is 100 km, time taken is 2 hours. So 100 by 2 is equal to 50 km per hour. It means that the car is moving at a speed of 50 km per hour. But there may be chances that during the 2 hours of traveling, the car may have moved slower than 50 km per hour for some time, or moved faster than 50 km per hour for sometimes. The average speed, without taking into consideration the faster or slower the car moves, we consider it moving with constant speed and use the term average speed instead of speed. Thus average speed can be calculated as average speed is equal to total distance covered by total time taken. And speed is the distance covered by an object in unit time. Speed is the distance traveled by an object in unit time. Average speed is the distance traveled by an object to the total time taken. A bus travels 200 meters in 40 seconds. Calculate the speed of the car. Speed of the bus. Distance covered 200 meters. Time taken 40 seconds. So speed is equal to distance traveled by time. Speed of the bus 200 by 40. That is, if we divide 200 by 40, we get 50, and the unit of speed is meter per second. How long will a car traveling at 60 km per hour take to travel a distance of 360 km? Here, the speed of train is 60 km per hour. Distance to travel 360 km. So speed is, we know that speed is equal to distance traveled by time taken. So time taken is equal to distance traveled by speed. So time taken is equal to, now put the corresponding values of distance traveled and speed. Is 360 by 6, that is 6 hours. Thank you.